Hello everyone, myself Yadagiri, Assistant Professor, Department of EEE, MLR Institute of Technology, Hyderabad. In the last session, we have discussed about the problems based on or numericals based on the RLC. So in this session, we would like to discuss about the problem based on the RL series circuit, RC series circuit, then RLC series circuits. So for this, we need to go with the first problem number 1, that is based on the RL series circuit. So that is given as a resistor of 20 ohms and inductor of 0.2 Henry are connected in series. So which is supplied from a 230 volts, 50 hertz is supply. Calculate the inductor reactance. Calculate the inductor reactance. Then next one is the impedance of the circuit. And third one is the current offered by the network and also the power factor of the system or circuit. Then need to find the power consumption taken by the RL series circuits. So the corresponding circuit we need to draw with the help of data is like this. This is the resistance, then this one is the inductance of the coil. So it has to connect to one power source, so which supplied by a 230 volts, 50 hertz. So the resistance offered by this one is a 20 ohms and it's a 0.2 Henry. So for every theoretical kind of question, we need to go through the given data. Based on that, we'll get the required questions. Required answers. So further we need to go with the given data. So in the given data, so R value mentioned as 20 ohms. R value is mentioned as 20 ohms. And the inductance of the coil is given as L equal to 0.2 Henry. And based on this one, need to get some voltage. So from the power source, that is a V equal to, it is 230 volts. It's purely RMS voltage only. So if it is mentioned like instantaneous values, then we would like to consider as the instantaneous value of voltage, that is. So means if it is mentioned like in terms of sine or cosine, then that is instantaneous value of voltage. So it was a RMS value of voltage. So for that frequency is a 50 hertz and nothing mentioned. So based on this one, need to find the inductor reactance, impedance offered by the network and also the current value and as well as power factor and also power consumption of the RLC series circuit. So for the very first question, that is XL they have asked. XL is, we have the formula XL. XL or omega L is called inductive reactance of the coil. So which is written as 2 pi FL. So 2 pi F is a 50, then inductance of the coil is a 0.2 Henry. And the XL value should be XL equal to, after simplification. So based on the simplification, we got that value is 65.83 ohms. So this is the first question answer. So inductor reactance of the RL series circuit is this one. So based on this one, I need to find the impedance offered by the network. That is the second question is impedance. So impedance is Z equal to R plus JX, R plus JXL. Then need to find the magnitude value, means the square root of R square plus XL square. So just now we have done about the XL, then substitute here, then we will get the impedance offered by the network. So that is a Z equal to square root of 20 square plus XL value means this one. That is a 65.83 whole square. So this is the impedance. After simplification, so we got this value as 65.94. 65.94 ohms we got. This is the impedance offered by the network. This is end of the second question. Next, third one is, according to the question, third one is the current value. So it is a ratio of the voltage upon impedance from Ohm's law. So if it is a DC network, we can consider as this one is. If it is a DC network, we can consider this one as it's the ratio of the voltage upon resistance. So because it is a AC circuit, so that due to the reactance offered by the network, the whole opposition offered by the network should be impedance, that is I equal to V by Z we got. So V means 230, Z means 65.94. So which value is, I value is it is a 3.49, I mean 3.488 ampere. So this is also RMS value. So that is a 3.488 ampere. So this is the RMS value of the current. After simplification of this one, we'll get the, so 3.488 ampere as current offered by the network. I mean current given by the source. Next, the fourth question is, so power factor. The fourth question we need to, finish. I mean we need to do in the next slide. That is question number 4. The question number 4 is power factor. question number 4 is the power factor. The notation of power factor is the cos phi. So according to the impedance triangle, it is a ratio of the resistance to impedance. It's the ratio of the resistance to impedance is the power factor. So the resistance value is mentioned as it is a 20, then impedance we got it as a 65.94. So therefore cos phi equal to 20 divided by the 65.94. So therefore the power factor of the system should be, or the circuit should be, we got as 0. After simplification, so 0.303 lagging, because it is an integrated network. That's why the power factor should be 0.3003 lagging. So 0.303 lagging is the power factor offered by the RL series circuit. Next question number 5 is the so that is school like I think power consumed by the network. So the power consumed by the network due to the resistance only, because there is no power, I mean there is no average power taken by the pure inductive circuit. The resistance added to the inductance of the any circuit or any coil, then we will get there will be active power consumption taken place. So based on that, the active power consumed by the RL series circuit is a P equal to then VI cos phi. So it is active power only. That means V is a 230, then current value is a 3.44, current value is a 3.88, I think 3.488. Yeah, it is a 3.488. Then power factor is a 0.303. So therefore the active power consumed by the network should be it is a 243.36 watts. So this much amount of power consumption taken place in the RL series circuit. So this is the end of the fifth question. So it's a power factor, lagging nature. Then this is the power consumed by the whole circuit should be this one. So this is the end of the whole first question. We have finished with Excel. I mean the net reactance, impedance, current, power factor, and also the power consumed by the network. So this is the end of the question on RL series circuit. So in the next question we need to discuss about the numerical based on the I think RC series circuit. So because the question mentioned clearly, it's a non-inductive resistance of 50 ohms is connected in series with the capacitance of 1 microfarad. So which connected across a 230 volts, 50 hertz supply. So we need to determine the capacitive reactance. And followed by the impedance offered by the network, and followed by the current offered by the network, and the fourth one is the power factor. So these many things we have to discuss based on the given data. So further need to draw the circuit diagram. So this is the 15 ohm resistance, so which connected in series a capacitance of the plate should be 100 microfarad, so which connected with an alternating source, voltage of 230 volts, 50 hertz. So based on this one, need to find these many parameters. So for this, so need to go with the given data. Yeah, we would like to go to the given data. So the given data will be, so that is a R equal to 15 ohms, C equal to 100 microfarad. So which means it is 100 into 10 power minus 6 farad it is. So need to convert the microfarad to farad, then we'll get the 10 power minus 6 farad. And applied voltage in terms of RMS is at 230 volts. Then frequency of the supply should be, that is F equal to 50 hertz. So based on this data, need to find the question number 1. So that is XC. What do you mean by XC? Means it is a capacitive reactance. It is a capacitive reactance. So symbolically it is represented by the XC. XC means 1 by omega C, which means 1 by 2 pi FC, because omega value is a 2 pi F. So based on this one, we will get the XC value is a 1 by 2 pi FC. If you are able to substitute the values of frequency and capacitance, then we will get the capacitive reactance value, that is a 50 into 100 into 10 power minus 6. So based on the substitution of these all values, based on these all so mentioned value, frequency and the capacitance value, then we will get the capacitive reactance should be. So the capacitive reactance should be XC equal to, so that is a 31 31.83 ohms. So after simplification of this one, we will get the capacitive reactance value. So this is the end of the first question. So it is symbolically denoted by the 1 by omega c, xc both same only. So which value is based on the given data, that is 31.83 ohms. So next question, second question is the impedance. Need to find the impedance of the network. That is the second question. Impedance is Z equal to R plus J xc it is. Then magnitude value should be R square plus xc whole square. I mean xc square simply. So then we will substitute the R and xc value. Xc just now we have done. Then R value mentioned in the question as 15 ohms. Then square root of 15 square plus 31.83 whole square. After simplification of this one, the impedance offered by the series RC network should be that is 35.187. 35.187 ohms we got. So this is the impedance offered by the RC series network due to the current flow. Then we will go to the next one. That is the question number 3 is the current value. Then so according to the Ohm's law, the question number 3, according to the Ohm's law, question number 3, that is capital I equal to V by Z. So V value as mentioned like 230 volts they have given in the question. Then Z value we got it as 35.187. Therefore the current flows through the RC circuit, RC series circuit should be 6.536 ampere. So ratio of the 230 volts to the 35.187 impedance of this network should be 6.53 ampere current flow. So this is the question number 3. Then question number 4 is the power factor. So very simple one, similar, it is similar to the previous problem. The power factor is we are going to getting from the impedance triangle. So that is R by Z, means impedance triangle is this one. We have already gone through this in the analysis of RL and RC series circuit. So this is the impedance triangle. So this is the theta or phi. So this is a Z and this one is a R, this one is a X. So from this one need to write the cos function, that is a cos phi equal to, so we will get R by Z means adjacent side upon the hypotenuse, that is R by Z we got. So from this one we will get the power factor of the RC series circuit is a R by Z. So R is mentioned in the question as that is I think 15 ohms. So XC just now we have impedance value just now we have done, that is 35.187. So ratio of the 15 divided by the 35.187. So which means the power factor offered by the network between the current and voltage should be 0.426 leading it is. So 0.426 leading. Why? Because the capacitance of the network, the capacitance of the network compensate the lagging angle of the power factor. So based on that we will get the leading power factor. So that is 0.426 leading nature. So in addition to that we also determine the power consumed by the network. So that is the active power taken by the network or the average power taken by the network is so P equal to VI cos phi. So which means it is the active power means resistance power only. So if it is a pure capacitor present in the network, the average power consumed by the circuit over a complete cycle should be 0. So if you are able to add the resistance, small resistance or any resistance value with series, I mean in series to the capacitance of the network, then that will create to consume the active power. That's why we will get the P equal to VI cos phi. And the average power taken by the RC series circuit, average power consumed by average power taken by RC series circuit should be this one. We did a resistance only. So that is a P equal to VI cos phi. So if you are able to substitute the voltage and current and power factor value, then we will get the active power consumption in the network. So this is the end of the second question. It was on RC series circuit. So based on the required credential, we got the answers about the capacitor reactance, impedance of the network, and also the current, and as well as power factor. Then question number 3, need to discuss about the question number 3. So the question number 3 mentioned like the resistance of the 12 ohms, inductance of the 0.5 Henry, and the capacitance of the 100 microfarads are connected in series, and the combination is fed by a 100 volts, 50 hertz AC supply. So determine or find the inductor reactance, then capacitor reactance, then impedance offered by the network is a Z, that is a capital Z, then current value, then power factor, that is a cos phi. Just now we have gone through the power factor of the RL and RC circuit. Then active power consumed, that is VI cos phi. Just now we have discussed about the active power. So these many parameters we have to discuss based on these many things. So further need to go through the given data. So need to write the given data of the network. The given data will be, so it's the given data. So the given data is a R value mentioned as 12 ohms. Then L of the network, inductance of the coil is a 0.515 Henry, and the capacitance of the parallel plates, that is 100 microfarad. So this combination is fed by a 100 volt supply. VRMS should be as a 100 volts, F equal to 50 hertz. Then based on this one, need to draw the circuit diagram of the question. So this is the R element, then inductor, then capacitor, which is fed from an alternating voltage source. The magnitude value of 100 volts, 50 hertz supply. So it is 100 microfarad, and this one is a 0.15 Henry, and this one is a 12 ohms. So based on this one, need to find the XL, XC, impedance, current offered by the network, power factor, and also the active power consumed by the network. So this one thing we need to find. So for that first question, that is XL. XL in the RL series circuit, we have just now gone through the XL value, that is 2 pi FL, which means omega L also we can take. So whose values are 2 pi into, that is a 50 into 0.15 Henry. So the inductive reactance offered by the network should be that is 47.123 ohms. So this is the reactance offered by this coil. So this coil offered some reactance. So there is a property of resistance, that is 47.123. Then question number 2 is a capacitor reactance. Question number 2 is a capacitor reactance, that is XC equal to 1 by omega C equal to 1 by 2 pi FC, because the omega value is since the omega value is 2 pi F means omega. So 2 pi F means omega, that's why we'll get 1 by 2 pi FC. Then 1 by 2 pi into, then 50 into the capacitance of the parallel plates is 100 into 10 power minus 6. So therefore XC should be 31.830 ohms. So this much amount of reactance offered by the capacitor. Next, go through the impedance. This one done, and we need to go through the question number 3. The question number 3, I think impedance it is. Impedance means it is a R plus J XL minus XC in this case, because the total impedance of the network should be, it is a XL and XC combination. So the magnitude value of this impedance is a square root of R square plus XL minus XC whole square we got. The resistance value, how much they have given, 12, and this one is a 47. This is a 12 whole square plus 47 point, how much we got, 47.123, 31.83. 123 minus 31.83 whole square we got. After the simplification of the the above process, I mean, so simplification of this above term, so we will get the impedance offered by the network should be, so 19.436 ohms. So this is the end of the third question, means impedance offered by the network, that is RLC series network, is a 19.436 ohms. Next we need to go through the question number 4 as a current. The question number 4 as a current, I equal to V by Z according to Ohm's law. Then V is a 100 volts, I think mentioned as 100 volts. Then Z is offered by the network is a 19.436. So Z is a 19.436. So ratio of these two, the I will be, I mean the current flowing through the network will be, so it's a 5.144 ampere. So this much amount of current circulating to the network due to the 100 volt supply. So this is the end of the question number 4. And what they have asked about power factor. So the power factor we need to determine from the impedance triangle. So from the impedance triangle, the cos phi equal to, it is a ratio of resistance to impedance. It is a ratio of the resistance to impedance. So just now we have gone through the impedance triangle. So this is the impedance triangle. Based on this one, cos function should be, it is a ratio of the resistance to impedance. So the resistance value mentioned in the question as 12. Then impedance just now we got 19 point something value. So therefore cos phi equal to, so it was I think 12, yeah, 12 upon then 19.436. So therefore the power factor offered by the network due to the power source, so that should be 0.617 lagging again. So 0.617 lagging. So this much amount of the power factor offered by the network. Then the last question is question number 6, I think. Yeah, 6th it is. The question number 6 is a power consumed and active power consumed by the network. Active power consumed by the network. So that is the presence of resistance only it has to consume. So that is a VI cos phi. That is none other than resistance power only, VI cos phi only. So because the average power taken by the pure inductor and also the capacitor should be 0 over a complete cycle. But we have added the resistance in series to the R and L. That's why there will be a active power consumption taken place. Due to that, the resistance offered by the network offered by the, so some active power, that is P equal to VI cos phi. So based on that, the voltage is 100. Voltage is 100. Then current is a 5.144. Then power factor is a 0.617. So therefore the active power consumed by the network is a 317.69 watts. So this much amount of active power consumption taken place in the network due to the resistance. So this is the end of the third question also. So till now we have discussed about the problems based on RL series circuit. So it is important in the examination point of view also. So then also we have determined the different parameters of RC series circuit, that is XC, impedance, and current given by the network is I equal to V by Z. It's a ratio of voltage and current, voltage upon the impedance based on Ohm's law, and also active power consumption and also the power factor of the network. So for RC series circuit we have done. So same parameter also we have discussed in the RL series circuit, and after that also we have discussed about the, so XL value, then XC value, then impedance value, then current value, after that the power factor of the network, then after that the active power taken by the network. So these many things they also discussed about or determined about the RLC series circuit. So these many things we have till now covered in this session. I mean we have covered the problem based on the RL, then RC, then as well as RLC. RL series circuit, RC series circuit, then RL series circuits. So this is the end of the session. In the next session, we are going to discuss about the resonance condition in RLC series circuit. Then after that, we will move to the three-phase balanced AC circuits. So thank you, Mandal. Thanks for watching. Have a great day.